Hi everyone, good morning. So today we're going to be covering Pythagorean theorem. So this is a review lesson. You guys will remember the Pythagorean theorem is a squared plus b squared equals c squared, and that's where a and b are the legs and c is the hypotenuse. Okay, so let's go ahead and do an example problem here. We're going to set up a triangle, and we're going to say that it has legs of 3 and a leg of 4, and we want to solve for this value of c here. So when we do that, we're going to plug this into our equation of that a squared plus b squared equals c squared, where a is 3 squared plus 4 squared equals c squared. Well, 3 squared is 9 plus 4 squared is 16 equals c squared. 9 plus 16 is 25 equals c squared. Well, how do we reverse operation the c squared? Well, we know that we can set c squared equal to 25, take the square root of both sides, and like we learned from last week, we know that square roots and squares simplify out, so we're left at c equals 5. Cool. Alright, well, let's go ahead and do another problem. Very similar here. We're going to set this triangle up, and I'm going to label it as 2, 4, and c. Now this looks exactly like the same problem, with a slight similarity, but also differences as well. So we're going to say a squared plus b squared equals c squared. We'll say that 2 squared plus 4 squared, because these are our two legs, equals c squared. Well, 2 squared we know is 4, plus 4 squared is 16, equals c squared. Cool. 4 plus 16 is 20, equals c squared. So I'm going to set this up here. I'm going to say c squared equals 20. We know we're going to take the square root. These simplify out, and this is where we get into that issue, is there is no perfect square for 20 here. So we want to break this down into parts. So we're going to have c equals, and we want to think of two numbers multiplied that give us 20. And I'm going to break that down as 4 and 5. 4 times 5 is 20. Well, we can say that's the square root of 4 times the square root of 5. And we know that the square root of 4 is 2 times the square root of 5. This is our answer here. So the techniques for Pythagorean theorem are the same. The only difference here is we have to break down this radical function. Now, I know you guys have also seen a tool where we can break this down using the division of 2 method. So you can factor out 2. You can say 2 times 10. We know we can break this 10 down by 2 times 5. And you select your pairs, and this is what you'd kick out. So then you kick that out, you get 2 square root of 5. Both ways are absolutely correct. Cool. Let's do another problem together. So let's say we have our triangle here, and we're going to go ahead and give it sides of, let's do x, 3, and 6. So this problem is different, as instead of being given the two legs, we're getting one leg and the hypotenuse. So when we set this up, we're going to say x squared plus 3 squared equals 6 squared. So we'll say x squared plus 9 equals 36. So when we subtract 9 from both sides, we're going to get that x squared equals 27. Well, with x squared equaling 27, we take the square root of both sides. Square and square root simplify out, so we're left with x equals the square root of 27. Now we want to break this down into factors. Well, we already see that we can't break this down by dividing by 2, so we have to think of other numbers that we can divide this by. I'm sure a lot of you guys are already thinking about it. See that 27 is divisible by 3. So we'll say x equals the square root of 9 times 3, because 9 times 3 is 27. And this works out nicely, as we can split this up as a square root of 9 times the square root of 3. And we know the square root of 9 is 3 square root of 3. Okay, so the Pythagorean theorem rules themselves, nice little review, not too difficult for you on these topics here. Now, what you want to be careful with is when we have to solve for these square root values that don't give us perfect squares. Okay, just as a reminder, we do have my office hours at 9 and 1, so please jump on if you have any concerns. And your assignment for this day for 413, okay, is directly aligned to this. Again, you don't need a calculator to be successful, but if you do, you guys already know how to get those. Okay, I hope this helps. If you have any questions, please hop on and we'll talk to you later. Bye.